My latest creation, a DC power load built with power transistors instead of FETs. The only reason for that is that I had an enormous amount of 2N3055 and I had no FETs at all, so the decision was easily made. In my Junck-box I found some heat sinks with already mounted 3055's. I removed those and selected 4 identical 3055's, so you have a more equal power distribution over the entire heatsink. I think they were from a Philips amplifier in the early days, in the 70s I think. The box is something I found also in the Junck-box, and you can quite easily use it without an Arduino, but I liked this display that I had and I want to use it, so I also inserted an Arduino for the display and for a few other purposes. If we have a look at the schematics, we see those 4 3055's.
The 4 power transistors are all in parallel, with individually emitter resistors, to equalize current consumption between them. Across the emitter resistors, a small voltage is present due to the current that flows through the 2N3055. One of the emitters is measured to give negative feedback to stabilize the current flow. Because the voltage can be very small, if the total current setting is low, the voltage in that case is no more than millivolts. An Zener diode is added to lift the voltage up, so it can be used as a reference for the integrated circuit. All 4 transistors are equipped this way, so for references are available for the Arduino to calculate the total amount of current through the 4 transistors. If no Arduino is used, these references are not necessary.
We see those 4 3055's, normally an output stage, but in this case it's an input stage. The voltage that you want the load on can be a power supply or a battery pack that you want to discharge. Anyway, these are the connections, the input connections of the power load. I used a fuse of 20 amps. You don't have to use 20 amps. You can have 30 or 40, whatever, but 20 amps was available here. The stabilization is accomplished with an LM741, again because it was available here.
The available integrated circuit controls the amount of current flowing through the 4 power transistors. Connected to its negative input is the information from one of the emitters. This is sufficient to steady the total current flow, a value that is controlled by its positive input. The total current setting is independently from the voltage that's connected to the power load. Current will not vary if the voltage is changed, so be careful while discharging a battery pack.
This is the front potentiometer and 2 small potentiometers to adjust the working area of this potentiometer, and it's a 10 turn, so you can adjust very precisely.
The voltage from this potential meter is connected to the positive input of the op-amp. And because of negative feedback from the power stage, the output of this circuit is very stable. The output voltage is going through a resistor to the buffer stage and inhibit transistor. By discharging a battery pack, the Arduino will look to a voltage drop on the load input. If this voltage drops more than 20%, the Arduino will send a positive voltage to the inhibit transistor. The load will be shut down and saving the battery pack. By not using an Arduino, or analog equivalent, this needs attention, so a battery pack will not be damaged. Although the overload protection was present in the original design, the automatic cut-off by discharging a battery pack is of a later date. This means an extra push button on the front to store the voltage value.
The buffer stage is built with a BC337 and a BD237. Why? Because they were available. You can use any transistor in that case almost. The BD has to be mounted on a small heatsink.
From the 70s on, a wide variety of 2 and 3055 are produced, with different ratings. From a maximum of 60 volts, up to 120 volts. And from 12 ampere, up to 20 ampere. So be careful with transistor you have available. Mostly a maximum power of 115 watt is given. The heat produced makes a good heatsink necessary. A good fan or ventilator is more than welcome if a high current and voltage is used.
So I used 4 of them, so around 200 to 300 watt continuously is the maximum on this heatsink. Well, that was it. It's very straightforward, and again, you don't have to use an Arduino. You can simply add a voltage and a current meter there, and you're done. See you in the next video. Bye bye.